Good morning, dear students. So today we'll learn something about the chapter motion. In the previous class, that is in standard 8, also you learnt about motion. And first I will recall the concept. I will not expand the concept. I will just recall the concept. And in this chapter we have to learn about motion and which are the different types in that, and based on that we have to solve problems. So plenty number of problems are there, as well as the nature of graph. So I'll start the chapter. First one, define motion. So first question arises in the chapter motion is, what is meant by motion? So for example, if you consider an object A at a particular point, then by applying the force or by the application of the force, the object will move from one place to another place. It may be move in a straight line or it may be move in a curved line. So that depends upon the applied force. So see here, object, this is the position of object A. Now that object A is reached to the other point. I will call that point as B. So object is to change the place from point A to point B. So that means there is a displacement or there is a change in the position of the object. So when by the application of the force, if an object is changes its place from one point to another point, that kind of motion, that kind of behavior is known as a motion. Okay. So when we consider the motion, in that it has two categories. One is distance and another one is displacement. Okay, you learned that in the previous class. Just give a small definition of distance. Comment me. So what is mean by distance? So I will draw the same diagram which you learned, maybe learned in the previous class. Point A and point B. This is one straight path which joins point A and point B. Just comment me what is mean by distance. Okay. Then another path. This is path 1 and I will call this path as path 2, and I will call this path as path 3. So here when you consider this path 1, path 2 and path 3, then in that case I will consider this distance as 50 kilometer, this distance as 70 kilometer, and this distance as 100 kilometer. So when we consider the distance, so it is the longest path, or it is a total path covered by an object to move from one point to another point. It is the total path covered by an object to move from one point to another. Distance means it is the maximum or total path, covered by an object, to move from one place to another. Okay, it is the maximum path covered by an object to move from one place to another. So when we come to the SI unit, the International Standards of Units, SI unit is meter. So all small letters, or we can write small m. Okay, we have to write METR in the small letters, otherwise we have to write that in small letter m. Okay, this is about distance, is the maximum path. Now we come to displacement. It is the shortest path covered by an object. See here, distance is maximum or longest path covered by an object, but displacement means it is the shortest path, shortest path covered by an object, covered by an object to move from one place to another, one place to another. So remember all the definitions and expression which I am going to give thoroughly, because so after this, after completion of this, we have to solve the problems based on these theories. Okay, so therefore careful. So displacement means it is the shortest path covered from one place to another place. Now when we come to the SI unit, SI unit of displacement is also meter, because we are measuring the length, total length. So we learnt that in maths. So the SI unit of length is meter, or sometimes we'll use kilometer. Okay, but kilometer, meter is the SI unit, or we can write this as small letter m. Okay, this is about distance and displacement. So now when we consider this figure, the path 1 is having 50 kilometer length to move from point A to point B, and path 2 is having 70 kilometer length to move from point A to point B, and path 3 is having 100 kilometer length to move from point A to point B. Now in this, which is displacement and which is distance? First comment me which is distance. First comment me which is distance here. So which path? Path 1 is distance, or path 2 is distance, or path 3 is distance? Comment me fast. Path 3 is distance, given by Chetan and Devraj. Any other answers? Sharada, Suraj, path 3. Then comment me which is displacement here. Which path is displacement? Path 1 is displacement, or path 2 is displacement, or path 3 is displacement? So just recall the definition. So displacement, it is the shortest path covered by an object to move from one place to another place, and distances, it is the maximum or longest path to move from one place to another place. So here path 1 is displacement because it is having only 50 kilometers, it is the shortest one, and path 3 is distance because it is having 100 kilometer length, so that is the longest when we compare these three paths. Okay, this is about distance and displacement. Next, the next part is speed. Okay, the next part is speed. Speed is, it is the rate of change of, it is the rate of change of distance, rate of change of distance. Okay, or we can call the rate of change of distance is called as speed, or we can tell the definition as the change in the position of the object, or the change or maximum change in the position of the object with respect to time. So instead of writing with respect to time, we can consider directly the rate of change. Okay, the rate of change means it is with respect to time. So as time goes, the position also changes. Okay, when we come to the SI unit, SI unit is here meter per second. Okay, all small letter METR bar SECY, all small letter, or we can write small bar small s, small m bar small s. Okay, this is the SI unit of speed. Why here we are considering in the denominator second? That is because, so it is the rate of change of distance. Rate of change of means it is the change of distance with respect to time. So therefore expression becomes speed equals to distance divided by time. distance divided by time. Here time is in the denominator, that means it is rate of change of or change in the distance with respect to time. Okay, this is about speed. Now when you go to velocity, so the speed means it is rate of change of distance. Now velocity means it is the rate of change of displacement. Okay, it is the rate of change of displacement. Rate of change of displacement. Okay, rate of change of displacement here is called as velocity. Next, when we come to SI unit here again meter per second, all small letter. Okay, in distance the SI unit is meter, and displacement SI unit is meter. Now when we come to speed and velocity, SI unit of speed is a meter per second, and similarly SI unit of velocity is meter per second, or we can write this as small m bar small s. Okay, so SI unit is plays very important role in the final answer. So along with the answer you have to write the SI unit, then only you will get the full marks. Then when we come to the expression velocity, that is equals to displacement divided by time. So rate of change of displacement with rate of change of displacement, or change in the displacement with respect to time. Okay, if we use the word with respect to time, then no need to use rate of change of, or if you use rate of change, then no need to use with respect to time. Okay, then the next one, acceleration. Okay, acceleration, so it is completely depend upon velocity. So acceleration, it is the rate of change of velocity, rate of change of velocity. Okay, so velocity is rate of change of displacement, and acceleration is rate of change of velocity. Okay, so SI unit of acceleration is meter, all small letter, bar second. Second is also all small letter, whole square, or we can write small m bar small s square. Okay, and then when we come to the expression, so your expression is different, the SI unit is different. SI unit means meter per second square, and then expression, that is acceleration, that is equals to velocity divided by time, velocity divided by time. So rate of change of velocity, or change in the velocity with respect to time. So this is about acceleration, velocity, speed, displacement and distance. And one more thing I want to tell you here is, here we wrote meter per second. So this meter per second we can write, or m bar s raised to minus 1. We can write in this form also. Okay, m bar s, we can write m s raised to minus 1. Similarly, this is similarly symbol, meter per second square. This is a SI unit of acceleration, that can be written as m s raised to minus 2. Okay, meter per second can be written as m s raised to minus 1, and meter per second square can be written as m s raised to minus 2. Okay, this is about the definition and SI units. Then comes another term, that is scalar and vector quantity. Scalar, the physical quantity that is having only magnitude. Okay, the physical quantity, the physical. Up to now, how many of you understood this? Just comment your name fast and click on the like button. about distance, displacement, motion, speed, velocity, acceleration, and their expression and SI unit. Okay, comment your name first. The next concept is scalar. Okay, next concept is what is meant by scalar quantity. The scalar quantity, the physical quantity that is having only magnitude is known as scalar quantity. Okay, now for example, object is moving from one point to another point, and it covers a distance of 50 km. Object is moving, or car is moving and covers a distance of 5 km. Okay, here magnitude is given, car is moving, so that is a primary concept here, and secondary concept is it travels a distance of 5 km, but which direction is not given. So here the physical quantity which is having only magnitude, then that kind of quantities we are considering in terms of scalar. Okay, and which physical quantity that are having magnitude as well as direction. For example, if I consider car is moving and it covers a distance of 5 km, and if I add another term to this, that is it covers a distance of 5 km in east direction or in west direction, then it converts into a vector quantity. That is the next concept, that is second one is vector quantity. Okay. Vector quantity means the physical quantity so that are having magnitude as well as direction. Physical quantity that is having magnitude as well as direction. Okay, magnitude as well as direction. This kind of quantities are called as the vector quantity. Here example is car is moving and covers a distance of 5 km in south direction. So here the term comes vector. Okay, this is about scalar and vector. So scalar quantity, the physical quantity that are having only magnitude, then we have to categorize that quantities as scalar. And if the quantities which are having magnitude as well as direction, then we have to call that kind of terms as the vector quantity. Okay, next concept is uniform and non-uniform motion. The next concept is uniform motion. So uniform motion, for example, if an object covers a distance of 5 km in 10 seconds. Okay, this is point A and this is point B. Object moves from point A to point B in 10 seconds and it covers a distance of 5 km. Then in the next 10 second, again 10 second, okay, point is C now. Again it travels a distance of 5 kilometer. Again it travels a distance of 5 kilometer. Then again it travels a distance of 5 kilometer in another 10 second. I will call this point as D. Then again it travels. Again it covers a distance of 5 kilometer. Again in same time, that is 10 second. Now it reaches the point E. So from A to B it is 5 kilometer, from B to C 5 kilometer, from C to D again 5 kilometer, and D to E again it covers a distance of 5 kilometer. And in all the intervals it takes the time as 10 seconds. To move from A to B it takes 10 seconds. Similarly from B to C, similarly from C to D, similarly from D to E, it takes a time of 10 seconds. So therefore, if an object covers equal distance in equal interval of time, if an object covers equal distance in equal interval of time, so that means by taking equal time, if an object covers equal distance, then that kind of categories or that kind of motion we are considering in the we are considering that kind of motion as uniform motion. Okay, I will write the definition. If an object covers equal distance or equal distances in equal interval of time, equal distance in equal interval of time, then we are calling that kind of motion as uniform motion. Okay, the next category, that is non-uniform motion. Non-uniform motion. Okay, non-uniform motion. So yeah, just in the previous, it is uniform means it covers equal distance in equal interval of time. Now non-uniform means if an object covers unequal distance in equal interval of time. So that is first one. Or if an object covers unequal distance in unequal interval of time. So that kind of motions are considered in terms of non-uniform. For example, I will draw the diagram. From A to B, the total distance is 5 kilometer and object takes 10 seconds to move from point A to B, and then to move from point B to C, here distance is 3 kilometer and again time is 10 seconds. Then in next to move from point C to D, the total distance is 7 kilometer and object takes 10 seconds. So if an object covers unequal distance in equal interval of time, here unequal distance it covers but in equal interval of time, then we can call that as non-uniform motion. Or if an object, for example, this is 5 kilometer, again it travels 5 kilometer, again it travels 5 kilometer. So point A, B, C, D, here it takes 10 seconds, here it takes 7 seconds, here it takes 3 seconds. So here also we have to call this kind of motions as non-uniform motion. Okay. Therefore, according to definition, if an object covers unequal distance in equal interval of time, if an object covers unequal distance in equal or unequal interval of time Okay, this is about non-uniform motion. Then Next we'll solve the problem. So very simple one, just you have to understand the concept. So before going to start solving the problem, so I will tell you one thing. So while solving the first given value, you have to consider as initial velocity, and second given value you have to consider it as final velocity. And while solving the problem, first you have to write the given data, then you have to write the rela- relevant formula to solve the problem, then you have to solve the substitute the values, and you have to solve the problem. After getting the final answer, you have to complete the answer with the help of writing the SI unit. Okay, first one I will solve. So open page number 101 in your textbook. Page number 101. How many of you understood till now? Just comment your name. How many of you understood? Just comment your name. Yes, Prakash. You can write any one definition. No need to write both the definition. Okay. If an object covers unequal distance in unequal interval of time, or if an object covers equal distance in unequal interval of time, so you can write any one definition. In that main concept, there is no match between the first motion and the second motion. So open page number 101, that is example 8.1. So here is the question, example 8.1. Okay, not Prakash, Srinidhi. You can write any one definition. The next one, example 8.1. An object travels 16 meter in 4 seconds. If an object travels 16 meter in 4 seconds and then another 16 meter in 2 seconds. So first an object travels 16 meter in 4 seconds and then another 16 meter in 2 seconds. What is the average speed of the object? Here they ask what is the average speed. So according to the definition of the speed, we know that speed is the total distance traveled divided by total time taken. So here what is given? An object initially travels 16 meter in 4 seconds, then it travels again 16 meter in 2 seconds. Now we have to find out the average speed of the object. The first example 1. Example 1. So according to the definition, according to the given question, so the total distance traveled. So first I will draw one small diagram here. The object moved from point A to point B. It travels a distance of 16 meter in 4 seconds. Correct? So because it is given that an object travels 16 meter in 4 seconds. The next one, after that the object again moves and travels a distance of again 16 meter. So now it reaches the point C, and now in this case it takes the time 2 seconds. Now we have to find out the average distance of the object or average speed of the object. To find out average speed of the object, we have to add the total distance, that means initial distance, and then in the second session it moves again 16 meter. We have to add the distance, and similarly we have to add the time taken to move the first 16 meter and as well as the second 16 meter. Okay, I'll write the total distance traveled by the object. First one, total distance traveled by the object. Total distance traveled by the object, that is equals to 16 meter plus 16 meter is equals to 32 meter. Okay, 16 meter plus 16 meter, that is equals to 32 meter. The next one, now we have to write the total time taken. Total time taken. Initially it takes 4 seconds, plus in the second session it takes 2 seconds. Totally it takes how many seconds? Totally it takes 6 seconds. Okay. Totally it takes 6 seconds. So the total distance traveled is how much now? 32 meter, and total time taken is here 6 seconds. Therefore now we have to find out the average speed. Average speed that is equals to total distance traveled divided by total time taken. Just substitute the values and comment me the answer. So total distance traveled is in front of you, and the total time taken is also in front of you. Just calculate substitute the values and comment me the answer. Do the calculation fast. So the average speed total distance traveled is 32 meter, and total time taken is 6 seconds. Comment me the answer fast. 6 ones are 6, 5s are 30, remaining is 2, dot it becomes 20, 6 3s are 18, then again remaining is 2, it becomes 20, 6 3s are 18, and so on. So therefore average speed is equals to 5.33. Here in the numerator it is meter, and in the denominator it is having second, so therefore it becomes meter per second, small m bar small s. Okay, don't copy the answer from the textbook, just solve and comment me the answer. The total average speed is equals to 5.33 seconds. Just look at the steps and the answer. Okay, I think everyone understood this. Just last, J Lakshmi, so you wrote m s raised to, so she wrote m bar s raised to 1. So when it is 1, no need to write 1. Okay, directly write m bar s. When it is square, so that is for acceleration, then you have to write m bar s raised to square. And Kavya Raikar, it is not 5.33, it is 5.33 meter per second. When you wrote the SI unit along with the answer, then only your answer gets certain value. Otherwise, no. Okay. Sometimes if you wrote little bit wrong answer, and if you wrote the correct SI unit, then also there is a chance of getting the marks. But if you wrote the answer also wrong, and if you not wrote the SI unit, then you will not get the marks. Okay, therefore be careful while writing the SI units and the final answer. Then next, example 8.2. Just read the question of example 8.2. Example 8.2. The odometer. So the odometer means it is the device which is used to measure the distance traveled by the vehicle. Okay, the odometer. Its working is, it is used to measure the total distance traveled. So in this question it is given that the odometer of a car reads 2000 km at the start of a trip and 2400 km at the end of the trip. If the trip took 8 hours, calculate the average speed of the car in kilometer per hour and meter per second. So SI unit of velocity or SI unit of speed is meter per second. But here the datas are given. So initial value is 2000 kilometer and then final data is 2400 kilometer and time taken is in terms of hours. The kilometer is not SI unit. Similarly, hour is not the SI unit of time. Therefore, either we have to convert or here it is given that find the average speed of the car in kilometer per hour. Therefore, don't change the value. First, use the values as it is and solve the problem and write the answer. And then they ask also convert that or also show that average speed in terms of meter per second. So when we want to show the values in terms of meter per second, then we have to convert kilometer into meter as well as hours in terms of second. Okay, first I will write the given data. So object is present, it travels a distance. So initial, okay, odometer means it is a device which is used to measure the distance traveled. So initial reading of the odometer. Okay, initial example 2. Initial reading of the odometer. So initial reading means before starting the trip. Reading of the odometer, that is equals to 2000 kilometer. This is the initial reading. And then so they started the trip and after 8 hours they ends the trip and the reading of that odometer now becomes 2400 kilometer. So therefore I will write final reading of the odometer. Final reading of the odometer, that is equals to 2400 kilometer. So initial reading is 2000 kilometer and final reading is 2400 kilometer. That means now we don't want the initial and final. Now we want the total distance traveled. So for that we have to subtract the initial reading from the final reading. Then we will get the total distance traveled. Initial is 2000, final is 2400. Therefore 2400 minus 2000 kilometer gives the total distance traveled in that trip. Therefore total distance traveled equals to, so I will write here final reading minus initial reading. Final reading minus initial reading. So therefore total distance traveled that is equals to how much? Comment me the answer first. Substitute the values and subtract and comment me the answer first. Final reading is how much? 2400 minus initial reading is 2000. Therefore total distance traveled is how much? 400 kilometer. 400 kilometer. This is the total distance. Now total time taken also given. So I will write that value. Total time taken that is equals to 8 hours. 8 hours is the total time taken to travel a distance of 400 kilometer. Now comment me what is the average speed in this trip? What is the average speed in this trip? So according to definition, we know that average speed, that is equals to total distance traveled divided by total time taken. Total distance traveled divided by total time taken. So therefore average speed becomes average speed, that is equals total distance traveled is 400 kilometer and total time taken is 8 hours. Just comment me the answer fast. So what is the average speed? Fast. Eight ones are 8 5s are 40, then 0, it is equals to 50, and distance traveled is in terms of kilometer and time taken in terms of hours. So therefore the average speed is equals to 50 kilometer per hour. Tejashwini, your answer is correct. Any other answers? Kilometer given by Ningappa and Priyanka, and Nagraj gave 50 meter per second. That is the wrong answer. Okay, you have to see the SI unit also. You have to see the units of the given data also, because the distance is given in terms of kilometer here and time is given in terms of hours. That's why the average speed becomes in terms of kilometer per hour. So therefore average speed is 50 kilometer per hour. Then also they ask convert the or show the average speed in terms of meter per second also. To write that average speed equals to 50. Kilo means 1000, per hour means for 1 hour 60 minutes, and for 60 minutes again, for 1 minute again 60 seconds, therefore it becomes 3600. So 0 0 gets cancelled. Similarly 0 0 gets cancelled. 2 5s are 10, 2 18s are 36. So therefore it becomes 50 into 5 divided by 18. So that is average speed. That is equals to 50 into 5 by 18. Average speed is equals to 50 into 5 divided by 8. So it becomes 13.9 meter per second. 13.9 meter per second. So that's why, so whenever you want to convert a unit that is from kilometer per hour to meter per second, then you have to multiply with the help of 5 divided by 18. Okay, so whenever you want to convert a kilometer per hour unit to meter per second, then you have to multiply the value with the help of 5 divided by 18. So because here the kilometer means 10 raised to 3, that means it is 1000, and denominator is having hours, that means for 1 hour 60 minutes and for each minute 60 seconds. So that's why 60 into 60 it becomes 3600. So when we cancel that, it becomes 5 divided by 18. Okay, that's why to convert the units you have to multiply with the help of 5 divided by 18. That is very important. Then next problem, that is example 8.3. Just read that question. Example 8.3. Usha swims in a 90-meter long pool. Okay. She covers 180 meter in 1 minute by swimming from one end to another and back along the same straight path. Find the average speed and average velocity of the Usha. Thus, Usha swims in a 90-meter long pool. The total length of the pool is how much? 90 meter. She covers 180 meter in 1 minute by swimming from one end to other and back along the same straight path. Find the average speed and average velocity of the Usha. So we have to find the average speed as well as average velocity of the Usha. First, I will draw one small figure here, that is example 3. Total length of the pool is how much? 90 meter. This is A, this is B. So Usha starts swimming from point A and she reaches point B, and then again she come back and reaches the initial point, that is A, in 1 minute. The total time taken to for the motion is 1 minute, and the distance traveled is 90 meter plus 90, because to move from A to B she takes 90 meter, and to move from B to A again she takes 90 meter. So that's why 90 plus 90 it becomes 180 meter. So that is given, and for that she takes time of 1 minute. Now we have to find out average speed as well as average velocity. We have to find out average speed as well as average velocity. We have to find out. Okay, first I will write total distance traveled by Usha. Okay, total distance traveled by Usha is how much? 180 meter. 180 meter, that is the total distance traveled. And total time taken. Total time taken, that is equals to how much? 1 minute. And so we have to either convert the SI unit in terms of if the values are not in terms of SI unit, then first we have to convert the values in terms of SI unit. So here distance is in terms of meter and time is in terms of second. That's why I will convert this time also in SI unit. So for 1 minute it is having 60 seconds. So now I have to find out the average speed. Therefore, average speed is equals to total distance traveled divided by total time taken. Therefore, average speed. So just substitute the value and comment me the answer. Average speed, that is equals to. Just substitute the values in the expression and comment me the answer fast. So your total distance traveled is how much? 180 meter, and total time taken is how much? 60 seconds. So now just cancel the terms and comment me the answer. Fast. Zero gets cancelled. 6 ones are 6 3s are 80. Therefore, average speed is equals to 3 and unit is meter per second. Next, I have to find out average velocity. Okay, Sharda, your answer is correct. 3 meter per second. Any other answers? Yes, Jyoti, Jeevan, Give the correct answer, that is 3 meter per second. Shreya, Suraj, 3 meter per second. The next, average velocity. Therefore, average velocity that is equal to total displacement divided by total time taken. Total displacement divided by total time taken. So here I'll write one reason: initial and final point. Initial and final point of Usha is same, therefore displacement equals to 0. So because if initial and the final point both are same, then the displacement becomes 0. Okay, but the distance does not become 0, it becomes 2 times, but distance becomes 0. Okay, so therefore average velocity becomes total distance displacement is 0 and total time taken is again 60 second. 1 minute is given, that means it is 60 second, so it becomes 0. We can write 0 meter per second, or simply we can write 0. So therefore the average speed of Usha equals to 3 meter per second, and the average velocity of Usha, that is equals to 0. How many of you understood this? Just comment your name. Just comment your name fast. So all the definition, and I solved now 3 problems. Up to now, how many of you understood this? So very simple concept, and based on that we have to use that definition, and we have to solve the problem. So while solving the problem, just keep in your mind, first read the question carefully, understand the problem carefully, and then first write the given data. That is very important. So whatever is given, first you have to write that, and after that find out the relevant formula to solve the problem and write that formula, and then substitute the value and do the calculation which involved in that, and after that write the final answer along with the exact SI unit. Okay, or use the accurate unit to complete the problem. Okay everyone, I'll continue in the next class.